All right, and we're back live. Wonderful, wonderful, wonderful. Okay, so I'm going to give people an opportunity in the chat to get in there. I have a lot to unpack this morning just because of the circumstances of yesterday. Yesterday, I did not have you. Yesterday wasn't A day. Yesterday, I was proctoring an AP exam, as a couple of you do know. Yeah, I can't even remember the name of it already. English comp something. What was it? What? It's a made up subject. Yeah, no. But I just wanted to just fill you in on some of the things. So first of all, the trailer that you guys will be taking your exam in first, to their credit, it's not as bad as they made it out to be, but it is, just frustrating to say the least. So I went over there. Hold on, I got to untangle my cord here. I went over there yesterday morning because they were taking their exam at like 8 a.m. And I go over there and I was told, hey, someone will be there to unlock it for you. Nope. So I'm standing out there. Now, I don't know, most of them showed up around like 7:30, like 7:30 on the dot. I was there at like 7:10, standing there like a joke. Hold on one second. I got to saunter over here and untangle my cord at the same time. There we go. So apparently the person who was supposed to unlock it left a message for a second person who was supposed to do it for them, who didn't show up until Miss Gerke, who I had left a message for because she was in the conference room for some other meeting. She had to run over, and she came over like 5 seconds after somebody unlocked it. It was a mess. Oh my gosh. So this place is basically just cavernous. They have just tables set up for you guys. The reason why I'm kind of upset about it is because when you take your AP test in that trailer, there will be a second AP test happening in the same trailer. Did you know that? Yeah, I didn't hear you. Supposedly, it's going to be happening in one of the conference rooms next door, but who the heck knows how that's going to work out? I really don't know. And I don't know. I'm just very frustrated that they're moving the AP students to this trailer, which, okay, yeah, I understand, they want the quiet or whatever, guys, maintenance guys walking out front, mowing the lawn, making noise, whatever. But like, they're putting you in a trailer when they spent how much money on that football field? I'm being honest with you. Like, I am very frustrated. Goodness gracious. Like, you guys are taking an AP course, an advanced placement college credit course in the midst of a pandemic. It was not fair to my last year students who had to take the test under those circumstances right at the beginning. It is not fair to you guys now, but you guys are going through it. And they're just like, yeah, just throw them in the trailer. It'll be fine. We'll turn on the air conditioning. We'll clean it out. We'll put up a new clock that they can actually read. I heard they switched out the tables, actually. Did they? What were they originally? Like legit wood tables from like what, the 80s? Nice. And they switched them out for these like little plastic things. Like, I'm sorry. You could go one day with teachers just being like, hey guys, let's avoid this hallway. Like down in A wing, there's a couple of classrooms down there. What? Okay. I just want to rant. That's all I really want to do is rant. And then I find out, remember that survey I had you guys fill out about the bus riders, right? There were, let me count them, 1, 2, 3, 4, 5 of you that they said, Ms. Gerke sent me an email. I'm not going to share names right now, but she said, these students will have a bus ride over to the exam location. Transportation won't drive you back. I'm going to let that sink in for a moment. I'll explain. This is what I was told. You can tell I have a smile, but it's kind of like a angry smile, can't see it. So they're just like, yeah, they're going to be, we can move them over, whatever, drive them over at 11:30, and they could take their test at 12. But then transportation's like, why would we drive them back to the school at like 3:30? There's no point to that. And I'm like, cool, great. So the arguments were made. Miss Gerke fought on your behalf. She did. But this is she basically said she did not win. So this is the email that I got. These students will have a bus ride over to the exam location. There's the list. I mean, you know who you are. But as in any year with the 12 o'clock exam time, they will need their own ride home. So that's where we're at.
If we needed transportation to get there in the first place, how are we going to get back?
How do they expect us to have transportation back?
Thus my ranting.
No sense.
Thus my ranting. It's been an interesting 24 hours, to say the least. Oh, man. It's like, I don't know. Some years we joke about there's like a spinning dartboard in the board office, and they're just like, all right, what can we mess up this year? Boom, and they throw a dart and they're like, yes, let's mess up buses this year, you know, or whatever. I don't have an answer for you now. We have, what is today? Today's the 6th. I have 2.5 weeks to figure out an answer for you. I don't have one. And once we hear anything, I'll be able to pass that along to you. But until then, that's the circumstances that we're faced with. So, yay. At this point, it's just like, man, all I'm hearing is just like, well, you know, we're sending this many kids to college and we have this many kids taking AP testing and blah, 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 blah. And I'm like, okay. Why are you treating your AP students like this? You know, let's shove them in a trailer. Let's bust them somewhere and not give them an opportunity to get home. I don't know. It's just one of those days. But yeah, that's where we're at. So notice my frustration. At this point, like I'm thinking like when I was in when I was in high school, there wasn't a Barnegat High School when I was a teenager, so I went to Southern. So yay for Southern. But I remember taking like my AP exam in like luxury almost. It's like we were in this like one like giant like oval conference room and in the board office, and it was just like they wanted us to like have like the circumstances like this is the testing environment. And I'm thinking about the environment that I took my AP testing in versus you guys in a pre-K trailer. You know, it sounds ridiculous, but at this point, I mean, in this past year, can you imagine like how much more ridiculous things can get? Ah, goodness gracious. Anyway. Yeah, guys, open your windows. It's a wonderful day. You know, we'll turn on the air conditioning after Memorial Day, right? I know. Fun stuff. I want to rant some more, but I'm like running out of material. And I'm all amped up. I don't know if you can tell. But yeah. But yeah, like I said, you know, it's the trailer's not as bad as I originally thought it would be. It was just, you know, one of those things. So, yay. But yeah. We have about 2.5 weeks until this AP test. And at this point, like, I seriously, like, I always imagine mathematics problems as a fight. And this is me personally. I always imagined a mathematical problem as a fight. Here's the problem that's in front of me. How can I best attack it? How can I literally, and this, I'm not even kidding you. This is what I thought to myself when I was in high school and college. How can I look at this mathematical problem? How can I grab it by the throat and squeeze the life out of it until it gives me the answer that I need, which is the correct answer? How can I do that? And at this point, like, this is how amped up I am. Like, I don't know. I want to get a fake ID and just kick this test in the head, you know? Fake ID and actually take the test with you guys. Not for you guys, just with you guys. Just because I'm just so like, I need to put my frustration out on something. And usually I put my frustration out on like mathematics problems or something like that. Lately, I've been turning my frustration to chess. But I don't know. I want to do math. That's what I want to do. I don't know. Can I sound any more nerdy, by the way? I'm just pointing that out. Okay. Rant over for now. For those of you in the live chat, I do see 7 or 8 of you in the live chat. If you would make sure you've left a comment. If you have not already done so, I can take care of that attendance in due time. Here's my plan for today. Number one, I want to do a couple of chi-squared problems. We've been working with chi-squared, learning the ins and out of chi-squared, seeing examples with chi-squared, but now I want to actually say, like, okay, here's a chi-squared problem. How do we attack it? And I have a couple of those that I'm going to make available to you on Google Classroom, actually. So I will give you the heads up while I'm going through my plan for the day. You will need those Chromebooks to read those problems. So just giving you the heads up if you don't already have them out. After said chi-squared problems, I want to go back to, we took this, man, maybe like a month and a half ago or something like that. No, it was like right before spring break or something around that. I gave you a multiple choice inventory. If you guys remember that, there was like a 2012 multiple choice inventory, and we stopped around number 22. Together as a team, as a group, I want to continue working through those problems and seeing what else we need to face. What other problems do we need to attack? Things of that nature. So that's what I would like to mainly focus on for today. So if you don't already have those Chromebooks out, please get them out and logged on. I'm about to share with you a PDF that I have locked and loaded right here. Let's see, PDF for today. Post. Boom. There we go. So get that PDF open. I'm going to bring it open over here. Come on, you. No, it was this one. There we go. I'm going to open them up as well. Oh, that's what I also wanted to rant about. Sorry, I'll tell you in a minute. Hold on. Let me get this window open a little bit more. There we go. The school does not own enough TI 84 calculators for a class of 25 students. So if you do not have your own TI 84 calculator, for the AP test, I'm going to have to provide for you the rinky-dink 83 calculators. So not to kick you while you're down. It's been a day. Like, it's been a 24 hours, let me tell you. I'm going to open this door a little. Hold on. I am sweating. Multi-million-dollar school. Let's spend all this money on a concession stand. Can't turn on the air conditioning. You guys remember how much that concession stand cost, right? It was over $1 million. Yeah. Because the concession stand is at the top of a hill, and they have to have plumbing. So the plumbing, they have to get the water going uphill, and the thing costs a lot of money to install those pipes. I thought you knew this. Yet you're taking your test in a trailer. Anyway. That'd be amazing. It'd probably be better air conditioned. And we can grill up some stuff in between. Just saying. Anyway. Goodness gracious. Okay, so I have this thing open right here. AP Quiz A. I know it says Quiz A, Chapter 26. This is actually from one of the older textbooks, but that's okay. But what I want to do with you is I want to walk through some of these chi-squared type problems. Now, this problem doesn't specifically label itself as chi-squared, but let's read through it and pick up on some of those things. It says, a biology professor reports that historically, grades in her intro bio course have been distributed as follows. 15%, 30%, 40%, 10%, 5%, A, B, C, D, E, F. Or there's no E, this is just F, whatever. Grades in her most recent course were distributed as follows. It says to test an appropriate hypothesis to decide if the professor's most recent grade distribution matches the historical distribution, give statistical evidence to support your conclusion. This is a chi-squared problem. Not only is it a chi-squared problem, it is also a chi-squared goodness of fit problem. It is a goodness of fit GOF problem. The reason why is because you are comparing a theoretical model versus an actual observed model. Now, the theoretical model is what the professor believes. It's what the professor reports. Historically, grades in our bio course have been distributed like this, meaning this is the generally accepted null hypothesis. This is the way that the professor believes every class will average out to be approximately. It's like the genetic theory of earlobes versus rolling of your tongue. Gosh. By the way, is there anyone who can't roll their tongue and has their earlobes attached? No? All right, let's check. You have to check your earlobes? You guys have been alive for like how many years? You don't know what your earlobes. Here, I'm going to do an experiment. Okay. Pretend like you're making a phone call. Pretend with your hands. Pretend like you're making a phone call. Okay. You see how most of you are doing this, right? Have you ever truly used a phone that looks like that? Some of you have. If you go to my 7-year-old or anybody who was like maybe under the age of 10 and ask them the same question, they're going to do this. Anyway, back to this. I don't know. I have no idea. But shut up. Anyway, so this is the generally accepted numbers 15, 30, 40, 10, 5, but we're comparing it against the observed counts of, well, whatever these numbers are. I don't even know how many students are in the class, but we'll figure that out in a moment. There are 5 categories that have counts in them. This is counted data with multiple categories. This is a chi-squared problem, goodness of fit. It says to test an appropriate hypothesis to decide if the professor's most recent grade distribution matches the historical distribution, give statistical evidence to support your conclusion. So here's what we're going to do. I am going to go to my notes. I know that most of you already have your notes open, which is fantastic. Good for you. Let's see here. Get some paper. Get this thing rolling. There you are. My fancy marker. I'm just going to mark up my paper real quick just with some information. I'll give you the title in a moment. Good. Has it gotten hotter in here now that I've opened the window and the door? Goodness. People like, Mr. Markey, put a wet paper towel on the thing. It's never worked. It's never worked. Put a wet paper towel? No, it won't work. I'm telling you. Oh, zooming out. There we go. So that's just what I'm titling it right there. I'm just going to give myself some information here. I'm going to go through the whatchamacallit. I can't even think today. The hypothesis test with the hypotheses and the assumptions and conditions and all of that stuff in between. But first, I just want to organize my information here. So observed data versus expected data. So let me go to the observed data first. The observed data, there were 89, 121, 78, 25, and 12. And you can see that there. That is my observed data. Now I'm comparing it against the expected data. However, they didn't give me the expected data in counts. They gave me the expected data as a percentage. I'm not writing down the percentage. I have to write down the expected counts. So what I'm going to have to do, they didn't even tell me how many kids were in the class really until I actually add up these numbers. 225? Oh, I got 325. I thought you said 220. Did you say 225? Okay, whatever. It's no 325. 325. There are 325 students in the class. So what we're going to have to do with each of those percentages, let's say, is we're going to have to multiply those percentages by 325 in order to get the expected count. That is vital. You cannot just put in the percentage. So there were 15% A's. And yes, I'm going to put down the full decimal. There were 30% B's. There were 40, 10, and 5. Okay. 40, 10, and 5. There we go. Now, you are going to have to do this for assumptions and conditions. You are going to have to do this for assumptions and conditions, but what is the bare minimum for the expected counts? What do you have to make sure of that each expected count is greater than or equal to? 5 in this case, yeah. It's usually like 10 when you're dealing with a proportional z-test. But for chi-squared, the expected counts have to be 5 or greater in every category. And yeah, that's fine here. I just wanted to kind of confirm that. Something that you can do in lieu of like, okay, well, I'm going to have to go through this whole hypothesis test. Okay, I will have to go through this whole hypothesis test. Ugh. But we're going to have to use these TI-83s. And the TI-83s don't have a goodness of fit test. So I did talk about this the other day, but I am going to walk you through again how to do this without that goodness of fit test on the calculator. First, I'm going to go to my list. I'm going to suggest that you try to get the practice with this with your Chromebooks open. You have that calculator open and you enter in the appropriate data. But I'm going to enter in 89, 121, 78, 25, and 12. That is my observed data. 48.75, 97.5, 130, 32.5, 16.25. Cool. Now, just again, thinking about assumptions and conditions. Thinking about assumptions and conditions, because I will have to write this down. They did talk about counted data, which we have. They have to have at least 5 in each expected category. Yes. What do you think about the 10% condition? There were 325 students. Is it, I guess, fair to think, like, I don't know how long this biology professor has been teaching, but I guess you could say, like, yeah, 325. This biology teacher has probably taught more than like 3,000 students in her career. I'm just going to assume. I don't know. Probably more than 3,000. So 10% is reasonable. Randomness. It's an intro bio course. It's an intro bio course. I think it's fair to say that the selection of students, they're not randomly selected by the professor, but it's a random assortment of students who are taking the course. If it's an intro bio course. If this were like a, well, yeah, it may be even AP bio, but that's like high school. It's like college. If I'm talking like advanced molecular biology or something like that, you know what I'm saying? You're not going to have like a history major go into that. So most likely this class is made up of kids of all sorts of majors. Fair to say, randomness, and then, yeah, the independence of one student's grade to the next. I'm just kind of mentally preparing myself for assumptions and conditions. Well, let me go back to this. Okay. Chi-squared. Chi-squared. That formula will be given to you on the AP test. That formula will be given to you on the AP test. It's on the formula sheet. But chi-squared is the sum of all the cells of this calculation, where I believe it was observed minus expected squared over expected. And I'm going to show you again, remind you how to do that on the calculator. But again, that formula will be given to you on the formula sheet, so you don't have to worry about memorizing it. It's at the bottom of the third page. So I'm going to go to my calculator. I'm going to go up to list 3. And I'm going to do those calculations of parentheses L1 minus L2, close parentheses squared, because I put my observed in list 1. I put my expected in list 2, divided by expected, which is list 2. If you do that properly, it should populate that list. And then we're going to have to add all that junk up. Kind of makes sense. I mean, in one sense, they're trying to find the, I guess, the deviation between observed and expected. And yes, it could be positive or it could be negative, and they're squaring it to make it positive. But then they're dividing it by expected. It's a weird thing. I like it, though. Anyway, we're going to have to sum that up. Remember, you got to quit out of this. I'm going to get back to my home screen. Second mode will quit it back. Second list will bring you to the functions for all of the lists, especially finding the summation of that list 3. Second stat will bring you to the list functions, where you can sum up list 3 and get that number there. I'm going to write that number down. That number is your chi-squared test statistic. That is your chi-squared test statistic. I'll show you what I wrote down. Zoom out. There we go. That's all that I wrote down right there. Chi-squared equals that. You don't have to show the work for that. It's like, if you get that, they're going to assume that either you had the calculator just do it automatically or that you literally calculated it by hand. But that's what results as the chi-squared test statistic. I'm going to have to do chi-squared CDF. I am going to walk through my mechanics in a little bit. I just wanted to see what this turned out to be, just for funsies. Oh, I got to put in a third number there? What the heck was that third number? Which in this problem would be what? It is degrees of freedom, America.
4.
Why?
Because you have the 5 different counts of grades and then 1 less than that.
And that's the key, though, the 5 different counts of grades. I'm putting in a 4 and not 324 for 1 minus the sample size, because that is not what chi-squared is about. Degrees of freedom would be 1 less than the number of categories. So that's what I would have to calculate. Second vars, chi-squared CDF. That number, 62.538, comma, some big number, comma 4. Ba-bow! Holy crap. 8.5 times 10 to the negative 13, which is essentially 0. But we'll deal with that in a minute. Let me get my fancy 84 calculator. Do something similar. With the fancy 84 calculator, you're still going to have to type in the appropriate information into your list. So I'd still have to do 89, 121, 78, 25, and 12. I'd still have to do 48.75, 97.5, 130, 32.5, 16.25. I'd still have to do all of that junk. But, oh, it's not even on here? Wow. Do you see this 84 calculator and how rinky-dink it is? It doesn't even have the goodness of fit test. I thought it did. That makes me sad. Makes me so sad. I have to say sad like that. Come on, smart view, I guess. Gosh. Can you imagine last year taking the AP test? Last year taking the AP test, they all took it on their computers at home. But they did not have this program because I don't think, were we one-to-one? I have no idea whether or not we were all one-to-one last year with technology. Whatever, anyway. Oh, what a mess. There we go. Uh-huh. Oh, and you guys don't even have this fancy keyboard at the side, right? You don't have this like fancy number pad at the side that you can type. Yeah, it's so much easier with that. All right, stat. Goff. Degrees of freedom. Calculate. There it is. I mean, obviously we did it correctly. Obviously we get the same chi-squared statistic and the same p-value, but I just wanted to show you that we did it correctly according to what the calculator is saying. Boom. Back to here. There we go. So let's actually walk through the test. Let's walk through the details of what we'd have to write down, because that was just some side work that I wanted to do, and it'll save me some time in a moment. So, number one, hypotheses. Hypotheses. Now, I'm going to word this in the manner of the problem itself. So the problem is saying, decide if the professor's most recent grade distribution matches the historical distribution. Okay. I guess so. Most recent grade distribution matches historical distribution. I wanted to word it in the manner after the problem itself. I wanted to use their language with this. But yeah, with chi-squared, you're going to have to put it in words. And then the alternate is the most recent grade distribution. I'm going to abbreviate. Doesn't match historical distribution. And I'm going to abbreviate that as well. Appropriate. Let's see here. Assumptions and conditions. Counted data is, counted data is given, yeah. Counted data is given. I mean, like literally, they give you counted data, you know? Cool. Randomness of, let's say type of student. Randomness of type of student in class is reasonable. When I say type of student, I mean, like, you know, are they a science student? Are they a really good student? Are they dedicated? Are they just kind of like trying to get by? Are they just trying to hit some prerequisites? That whole thing. Independence of scores is reasonable. And again, I'm putting it into context. 325 is less than 10% of professors' student population. And I say that, I mean, that is kind of reasonable because, like, I've been teaching here. I mean, obviously, this is a high school, but not a college. And in high school, I teach, like, 20, 25 kids per class. I've been teaching for about 12 years here, 13 years overall. Probably I've taught somewhere between 1,000 to 1,500 different kids, somewhere in that range. But that's at a high school, like a medium to low size high school. If this guy's at a university, It's like, oh, it reasons, if you're teaching for any number of years, you're going to have thousands and thousands of students. And then, you could say at least 5 expected in each cell. I just say that because, clearly I labeled that up above. At least 5 expected in each cell. I'll move that up. There we go. So then we already ran the test. So the mechanics of it all is already taken care of. So I'm just going to jot down chi-squared equals 62.538 with a p-value of 8.5 times 10 to the negative 13th. In the past, you would literally write down like, okay, this is what I put in for the mean. This is what I put in for the standard deviation. This is what I put into the chi-squared test. And this is the p-value that popped out. Well, the numbers that you would type in, we literally did all those mechanics up above. These are the mechanics that you would do in order to get that p-value. So as long as you write this information down, you're golden. And then it's time for the conclusion. With a p-value so low, I'm going to put approximately 0. We reject the null. There is, I'm just going to say evidence to suggest, but like in reality, because it's essentially 0 in this point, it's like, there's overwhelming evidence to suggest. But there is evidence to suggest the most recent grade distribution does not match the historical distribution. At that point, the professor would then be like, well, why? Why? But, you can't answer that now. You don't have enough information to be able to answer that. If it doesn't match, then the professor would then investigate further as to why and how such a discrepancy occurred. But that's not up for you to do at the moment. If you look at the grade distribution, there were a lot more A's and B's and a lot less C's, D's, and E's. Maybe they all cheated. I don't know. It's possible. But that's what these students are going through. I don't know. Maybe it was a year where there was just a bunch more science majors. I don't know. Maybe it was like an 8 a.m. class. Whatever. I loved 8 a.m. classes. I once had a professor that taught an 8 a.m. math class, and like she always came into class, taught barefoot, and cracked open a Diet Coke at 8 a.m. She taught barefoot with a Diet Coke. I don't get it. Anyway, she's still teaching there. Anyway, back to this. Here's what I want you to do. On the next page of this PDF, by the way, they do give you this question. Actually, let's just talk about this. I'm not going to write this down, but we can talk about this. Which grade impacted your decision the most? Explain what this means in the context of the problem. That's actually kind of what we just talked about. Which one impacted it the most? Let me zoom down right here. If you're doing this by hand, you tell me which one of those grades impacted your decision the most. Yeah, and you can tell literally right here. You can tell by that list 3 by which one is the largest number. It's the one that contributed the most value to the chi-squared test statistic. So as long as you can kind of see that, it's like, oh yeah, that's the number that influenced it the most. A's and, well, C's really, but the reason why C's influenced it a lot, the reason why C's influenced it a lot is because C's went down. But it's really A's that went up the most. So it says, which grade impacted your decision the most? A's. Explain what this means in the context of the problem. There were a lot more students who got A's. And in fact, you can even say, based on this list 3, yeah, a lot more students got A's, but they came up from C's. And you even have the evidence to do that here. So now you even have more evidence. Okay, how did these historically C grade students all of a sudden improve to an A? Uh-oh. Now you, just saying, now you have a little more evidence to investigate, but that's circumstantial evidence at the moment. Statisticians are not interested in the reasons as to why. They just want to know, is there something going on? Look, I can prove there's something going on. This is out of the ordinary. Let's investigate further. But what I really want you to do is I want you to go to the next page on this thing. This is partially what we were doing the other day with matrices. And I want to give you an opportunity to attempt to go through this hypothesis test on your own. Now, I want to read it, and I want to give you a small block of time to just jot some things out. And then after that little block of time, then I'm going to go through it, and you're going to be able to see if you followed the proper procedures. It says, as part of a survey, students in a large statistics class were asked whether or not they ate breakfast that morning. The data appears in the following table. Is there evidence that eating breakfast is independent of a student's sex? Test an appropriate hypothesis. Give statistical evidence to support your conclusion. So now, just to kind of recap something before you kind of deep dive this, where did my piece of paper from the other day go? Where'd you go? I must have wrote you down somewhere else. But I had written down something along the lines of, I talked about the goodness of fit comparing observed counts to the theoretical model. The homogeneity was comparing the distribution of observed counts amongst different groups, which this could technically be in that realm. But also there is a test of independence, which compares if two variables among the same population are independent. This is that test. I want to see what you can do with it. You should have enough valuable information at the moment to be able to attack this problem most of the way. See what you can do. I give you the next little block of time. So here. You guys know what the octonauts are, right? Yeah. Most of you do, I hope. Did your generation grow up with octonauts? Or was it after you? Whatever. Anyway, so my daughter has been obsessed with Frozen and Elsa for like, I don't know how long. She's 3 years old now. She has recently developed a new obsession, and I am trying to encourage it as much as I possibly can. Just because I know all the words to every Frozen song and can sing them wonderfully. Just don't doubt me. But her new obsession is, here, I'm going to zoom in on this. This is what she colored this morning. It's a character from Octonauts. It's Tweak, and she's the engineer of the ship. And it's absolutely wonderful. Look how proud she is. I'm just saying. That's what she drew. Because she just got a stuffed animal of Tweak, and she was just like, yes. So this morning, I found her on the couch watching an episode of Octonauts while holding Tweak. I want to encourage that way more than Frozen until they come out with a Octonauts musical. And then I'll learn all those words. Okay, back to this. So, as part of the survey, students are asked whether or not they ate breakfast that morning. Cool. So the question is, like, if you are a male or a female, does that really indicate whether or not you ate breakfast? Now, if you just look at the numbers, it's one thing to be like, well, it seems like males are split, and it seems like females, a lot more of them ate breakfast. So let's go with that. No, you actually have to run the hypothesis test. So let's walk through that piece by piece. They want to know if there's evidence that eating breakfast, excuse me, there we go, is independent of student sex. So let's see. I'm going to walk through this example. Let's go with a null hypothesis. Well, simply put, we could say that they are independent of each other. But how to properly word that in the context of the problem. Again, I'm just going to use the wording on the problem as best I can. Yeah. Eating breakfast and a student's sex are independent. It is very important that you put the hypotheses in the context and wording of the question. Don't try to do anything out of the ordinary. Now, I don't want to use the word dependent. I don't want to use the word dependent. So you could do one of two things for the alternate hypothesis. One of two things. You could say that they're not independent, but I don't want to use the word dependent because dependent implies there is like a direct, almost a direct cause and effect. So you could either say they're not independent, which is what I'm about to do in a moment, or you could say that there is an association. You could say that there's an association. Association, that's an important word, though, because association typically referred to what we did with linear regression. Oh, there's an association between the two data points. It's like curving upward. Oh, it's a curve, but there's still an association. We're not saying that one directly caused the other. Don't do that. But there could be an association. Or I could just say, I'm going to shorthand it here, ... are not independent. I didn't feel like rewriting it all. Of course, if this were the AP test, I would rewrite it all. But I digress. Okay. Assumptions, conditions. Counted data is given. That's given in the problem itself. Randomization. I mean, let me go back to the wording of the problem. It doesn't say that the students were randomly selected, because randomness implies independence of their responses. but it says students in a large stat class are asked whether or not they ate breakfast that morning. Do you think the fact that you are all taking AP Stat would influence whatsoever what you ate for breakfast? I don't think so. This is a large stat class. It's reasonable. Okay, I guess, I mean, there's no randomness, but, and I'm going to put this, hold on. No randomness. Because keep in mind, I mean, you are AP statistics students, which means you are of a certain caliber of, intelligence. So it's not really a random selection. But again, I'm going to say no randomness, but how do I word this exactly? I don't want... There's no randomness, but selection of students should not influence whether or not they ate breakfast. There's no reason to suspect that anything's going to go wrong with this. Even though randomness is not here. I mean, like, there are some instances in which you're like, yeah, you need randomness in order to do it. I mean, if this were a question about academics or a question about, like, mathematics, then, yeah, we would definitely need randomness. But we're talking about eating breakfast or not. There's no reason to believe that the selection of students in a stat class would be influenced in this problem. We could also talk about the independence. It's, independence is reasonable. Independence of eating breakfast is reasonable. I'll tell you a story about Derek. I drove Derek to school every day of senior year. He lived around the block from me. And the kid it would be one of like three categories. He would either like just be barely rolling out of bed, or he would like jump in the car, or he would just be not going to school, And so, I would just hang out in front of his house for like 10 minutes and then I'd go if he didn't show up. So several mornings he would come in with like, breakfast. He'd come in with like a bagel, cream cheese and stuff like that. I'm like, oh, that's cool. And he'd have something for me as well, if I didn't eat. And then one morning he comes in with a legit bowl of cereal. And I'm like, what? And he's just like, what? Let's just go. So we drive to school, park the car. He leaves the bowl of cereal. I mean, it's eaten for the most part. There's some stuff at the bottom. I forgot about it. We get back in the car that afternoon. It stunk to high heaven because he left a bowl of cereal in my car. Oh, the stories you remember. I got to text them about that later. Anyway.
Do you remember what type of cereal it was?
No, I don't. I just, goodness gracious. He had his routines, It was breakfast and a morning cigarette. I didn't have one. I forced him to always have his hand just out the window. Because I didn't want my car stinking, but then the cereal. Anyway, back to this. And then expected counts. Now, expected counts, we need them to be greater than or equal to 5. Did anybody check them? Uh-oh. I mean, we should be fine, but I'm just asking if anyone checked them. It's difficult to check the expected counts for this problem by hand. So instead, have the calculator do it for you. Watch this. If I were to enter my data, second this x to the negative first power to get to the matrices and go over to edit, I can enter in the first matrix, which, by the way, this is what the first matrix should be. You don't have to put the totals at the bottom. The calculator already knows what the totals are. This is the observed data. The observed data. you don't have to type in matrix B. Instead, go over to the chi-squared test on the calculator. Oh, Mr. Rocky, expected is matrix B. Yeah, don't worry about it. That's not us. Sorry, I just added another thing to my rant. How hard is it just to reprogram something in the main office? Go to calculate. Boom. Now that data will become important for us later. But if you go back to matrices, all of a sudden, boom, matrix B is populated for you. Matrix B are the numbers of the expected values. 76, 114, 55, and 84. I'm going to copy those down. Not the whole number. I'm just going to copy down the rounded numbers. 76.2, 114.8, 55.8, and 84.2. Ah, there we go. That should be sufficient to show, yep, expected counts greater than or equal to 5. Check. And they're right there. The calculator does it for you. Have it run the test. It'll do the expected counts for you when you're doing the homogeneity or the test of independence. So we're good. Let's run this chi-squared test. Yep. Here are my expected values. I'm just going to, not my expected values. I already wrote down my expected values. My observed values. These are my expected values. My observed values were 66, 66, 125, and 74. I ran that chi-squared test. It spit out a chi-squared value of 5.34 and a p-value of 0.021. That's all the information that I would need to provide to those AP graders in order to confirm that I have the information that I need. I'm ready for my conclusion. Again, the calculator is going to do most of this for you, but you got to get there. And regardless of if you have the rinky-dink 83s or not, this test is still available to you. So let's see. With a p-value that small, I'm going to put in parentheses 0.05 is greater than 0.021. We reject the null. It's not overwhelmingly small, but it is kind of small. I mean, keep in mind there is a chance, of course, that you could have made a mistake, but we work with the p-value that was given to us. There is evidence to suggest you could say an association or a relationship. I'm going to put an association. An association between a student's sex and whether or not they ate breakfast. Or not they ate breakfast. I'll move that up. There we go. Now, you could go into more detail if you wanted to, although that's not entirely necessary. I mean, based on the observed data, I mean, you could say, like, you know, well, for males, it looks like it doesn't matter. It's split 50-50, but you could say something along the lines of, it appears or it seems that females are more likely to eat breakfast. You could say that, but it's not required of this. You're not required to comment on it. Yeah. So here's what's going to happen. I, at some point today, am going to give you an assignment on chi-squared that you're going to complete for me over the weekend. Just a few problems here and there, just getting some practice with it. You have the calculators on your Chromebook that can do the goodness of fit test. Good for you. But if you don't have the Chromebook calculator, if you have just a regular 83 calculator, that could work as well. I downloaded, I couldn't download Wabbit Emu on my my new phone, but I downloaded like this like rinky-dink calculator right here. It's an 84, but it's like this weird interface. I'll have to send you the name of it at some point. But there are a bunch of free graphing calculator apps out there that you can use. But it works. I mean, the interface is kind of dumb. I mean, you click it and like nothing pops up on the screen; it just pops up down there, and then you gotta like, oh, there's the chi-squared goodness of fit test, and then it's kind of a weird interface. I'm not really a fan of it, but there are ways of getting around the calculator. Anyway, okay. Here's what I want to do. I am about to reshare a PDF with you via Google Classroom. I want you to open it. So let's see here. If I can find it. Yep, I know where it is. I'm going to reshare it here. It's already been shared once. I'm going to share it again. Da-da-da-da. Where are you? I literally just had you. There you are. Chappelle. 2012. Multiple choice. Actually, you know what? I'm also going to put the answers in there as well. For funsies. Answers. Boom. Post. Boom. There we go. I'm going to open this up. We had left off. Oh, I already opened up over here. Good. We had left off at about number 22. Said like, okay, well, number 22, we're starting to get into problems. Actually, no, we did that one. But for number 23, let's say, we're starting to get into problems that may not be things that we've covered. Now, I don't remember exactly what most of these problems do. But what I want to do just for the rest of today, I kind of want to walk through some of these multiple choice questions. You don't have to keep track of whether you got it correct or wrong. I'm just going to suggest that as we're doing the problem, you make a personal choice for yourself to determine whether or not you got it right or wrong. Whatever information that I end up writing down for these problems might be a good idea to write down, but I'm not sure how much I'm actually going to write down. But I posted this in the Google Classroom so that you don't have to squint at the screen, just for the sake of argument. A local company is interested in supporting environmentally friendly initiatives, such as carpooling among employees. The company surveyed all of the 200 employees at the downtown offices. Employees responded as to whether or not they own a car and to the location of the home where they live. The results are shown in the table below. Okay, let me just look at this table. I'm not even going to read the question yet. Location of the home, they either live in downtown, elsewhere in the city, or outside the city. And then car ownership, yes, they own a car, or no, they don't own a car. Okay, that's cool. Which of the following statements about a randomly chosen person from the 200 employees is true? Ooh, interesting. Okay, which of the following statements is true, which means 4 of them are false, obviously, but about the 200 employees. Okay. If a person owns a car, he or she is more likely to live elsewhere in the city than to live in the downtown area of the city. Okay, if they own a car, meaning I'm only looking at this row, he or she is more likely to live elsewhere in the city. No, they're more likely to live outside the city. That seems to be wrong. I'll just mark it for myself. B, if a person does not own a car, which means I'm only looking at this row, he or she is more likely to live outside the city than live in the city. Oh, wait, let me go back a little bit. Elsewhere in the city. Hold on, let me go back a little bit. Hold on. You know what I did? I made a cardinal mistake. I didn't actually read the full response in my head. Do you ever read something and then like 2 seconds later, you're like, I don't remember what I just read? I do it all the stinking time. I got to go back to part A. If a person owns a car, let's mark this up, he or she is more likely to live elsewhere in the city than live in the downtown area. Isn't that true? Huh. And I just completely dismissed it because I didn't like reading the problem. That's probably one of the biggest complaints I get from students. They see the problem and they're just like, ugh, too many words. Don't you read English? Part B, though, let me just go through them just in case. Hold on. If a person does not own a car, meaning I'm looking at these numbers right here, he or she, if it does not own a car, he or she is more likely to live outside the city, that's this number, than to live in the city, which is downtown or elsewhere. No, that's not true. That's not true. C, the person is more likely to own a car if he or she lives in the city than if he or she lives outside the city. Whoa, okay, hold on. The person is more likely to own a car if she lives in the city. So if they live in the city, we are looking at these numbers right here, which that's 25 of them own a car. Then if she lives outside the city, 25 versus 35. No, that's not true. Go away. By the way, what did the answer key say for this one, for number 23? Because I posted that as well, didn't I? Does it say A? It does? Cool. I'm pretty confident it was A. See, the thing is with these problems, they're going to word them in such a way to mess you up. They're going to word them in such a way just to mess with your brain. And they're going to throw in all of these extra words because they hate you. They hate you as much as the people who sodded the football field. They're just going to do that because they're like, screw those AP kids. Football. I know they play more than football up there, right? Yeah, whatever. I don't care. The person is more likely to live in the downtown area. Wait. The person is more likely to live in the downtown area in the city than elsewhere in the city. What? They're more likely to live in the downtown area in the city. No, they're equal. That's 70 and 70. Okay. Again, the wording. The person is more likely to own a car than not own a car. Okay. No, that's 60 to 140. The answer is A. All these problems. See, the thing is, a problem like this, a multiple choice question like this, should be everyone getting it correct. But they'll word it in such a way just to mess with you. And then you're just exhausted and you're looking at these problems and all the words are blending together. We have to be able to decipher them. Goodness. You know what would be the absolute worst thing is if they decide to cut the grass just outside the trailer when you guys were taking the test. Can you imagine? Anyway, back to this. A random sample of 432 voters revealed that 100 are in favor of a bond issue. Okay. A 95% confidence interval for the proportion of the population of voters who are in favor of the bond issue is. Okay, first of all, tell me. You need to tell me right now. What answers can you immediately eliminate without having to think that hard? What answers can you immediately eliminate without having to think that hard? Because there are 3 of them that you can eliminate. A, B, and C. Why? Yeah. See, the thing is, there's 100 there. Boom, boom, boom. Those are all gone. Why? Why are they gone? You're dealing with proportions. This question, man, I'd love to see like the percentage of who chose what on this question in real life back in 2012. But those 3 are immediately eliminated because you're dealing with proportions, and it should be 100 over 432 as that p hat at the beginning. So yeah, that's taken care of. But then, square root, they're exactly the same. It comes down to the Z star. It comes down to the Z star. Somebody do this calculation for me in 1 moment. Somebody do this calculation for me in 1 moment. I'm just writing out what this thing is going to be. 95%. Da-da-da-da-da, da-da-da-da-da-da. That's 5% between the two. That's 2.5%, meaning this is the 97.5th percentile. I need somebody to go inverse norm 0.975. I need somebody to go inverse norm 0.975. What do you get? Because that my calculator's all the way over there and I can't reach it. Cool. Answer's D. Did it say that on the answer key, by the way? Cool. You get 1.96, immediately you can eliminate the other ones as well. In fact, you could probably eliminate these right off the bat, these two at the top, just because of those square roots. But yeah, even if you had no idea how to do this, you're giving yourself a 50-50 shot. You're giving yourself a 50-50 shot. It's about playing this is a casino game that we're all playing right now. Gosh. Casinos are a dangerous place. You know the big difference between casinos and where you're going to be taking the test? In the trailer? In the trailer, they'll actually have clocks. That's basically the difference. Everything else is exactly the same. Probably not. 25. The commuting time for a student to travel from home to a college campus is normally distributed, okay, with a mean of 30 and a standard deviation of 5. Again, I like to read the individual statement and just kind of absorb that for a moment. The commuting time for a student to travel, okay, is normally distributed with a mean of 30, standard deviation of 5. In my head, I'm immediately imagining, I may not draw this in real life, but I'm immediately imagining a normal curve with a 30 in the middle, like 35, 40, 45, 25, 20, 15. That's just what I'm imagining is happening. If the student leaves at 8:25 a.m., what is the probability that the student will arrive at the college campus later than 9 a.m.? Meaning they traveled 35 minutes or later. There's no sample size to speak of. There's no real indication as to what to do other than the fact that they say it's normally distributed. And this may help me here. So 35 minutes or later. Oh, look at this. I'm like visualizing this. 35 minutes or later. There's two ways of doing the problem. Two ways of doing this problem. You could do the empirical rule, or you can do normal CDF, 35, comma, big number, comma, 30, comma, 5. Remind me one more time. What was this percentage right here for the empirical rule? Ooh, I'm putting you on the spot. It's been a while. Between positive 1 and negative 1 standard deviation, what percentage of the data should I have? 68. Remember, it's the 68, 95, 99.7 rule. That's 68% of the data, meaning that there's 32% split, meaning this is 16%. Doing that calculation would get something approximately 16%, but there's a 16% chance that the student will arrive later than 9 a.m. I'm assuming the answer key said A. No one wants to respond. It didn't? Oh, it did. You scared me. Don't do that. Anyway. But yeah, you could use the empirical rule in that one. Let's see what the next one says. Holy crap. Okay, here we go. Lots of numbers. In 2009, a survey of internet usage found that 79% of adults age 18 or older in the US use the internet. A broadband company believes that percent, or the percent, is greater now than it was in 2009 and will conduct a survey. The company plans to construct a 98% confidence interval to estimate the current percent and wants a margin of error to be no more than 2.5 percentage points, assuming that at least 79% of adults use the internet. Which of the following should be used to find the sample size? Interesting. Okay. What this is using, by the way, what this is using is p hat plus or minus z star square root p hat q hat over n. And it's looking at the margin of error, which that is the margin of error. They're looking at that to help calculate what the sample size should be. First, I need you to do a calculation for me. This will be the last question that we do, but I need you to do a calculation for me. I need you to do a calculation for me. Hold on. 98% confidence interval, meaning this is 1% right here, meaning this is the 99th percentile. I need someone to do inverse norm 0.99. Inverse norm 0.99. What do you get? 2.33. Meaning you can eliminate those as choices. They're saying to assume that 79% use the internet, meaning you don't have to do this 0.5 crap. They are assuming 79%. So in that fraction, it should be 0.79.21. And they did say they want the margin of error to be no more than 2.5%. Did the answer key say D? Heck yeah. Process of elimination. You don't even have to do any real calculations beyond that inverse norm. But by doing that inverse norm, you immediately eliminate two of your options. Oh, it's a game. That's all it really is. Okay. You're going to get some chi-squared practice from me. I'm going to assign that before I leave here today. If you have not left a comment in the chat, please make sure that you do so. For those of you who fell into that bus category issue from earlier today, like I said, I'll see what I can do. I'll see who I can talk to, but like I said, Miss Gerke has been fighting for you guys like you wouldn't believe. And she hasn't really made much headway. She fought for me yesterday a bit too, but didn't work out. Didn't work out. But anyway, I'm going to sign off in the live chat in a moment, and then we'll see where we go from there. Woo! It's already Thursday. My gosh.